Hey, what's up, my compadres? Today we're going to be talking about factoring when a does not equal 1. Now, full disclosure, this is probably going to be the most tedious type of factoring that you do on average because it takes about twice as much guesswork as normal factoring when using the typical approach that people take to tackling these problems. Notice that I use the word tedious here and not difficult. When thinking about how to approach these problems, I'm going to consider the foiling algorithm that I normally use to multiply out two binomials. Specifically, I'm going to consider the fact that only my outer and inner products combine in my final answer. In other words, my first and my last term are unaffected by my two middle terms. Now, what does this mean for us in our factoring here? Well, it means that we're going to be looking for two terms that multiply together to give me my first term, and two terms that multiply together to give me my last term. Very simple, right? Now, the tricky part, and honestly the most annoying part, is in finding the combination of factors that will combine together to produce my middle term if I were to FOIL out my answer. Let's see what that looks like in action. Our first example is 3x squared minus x minus 10. This time I'm going to be looking for two numbers that multiply to 3 and two numbers that multiply to negative 10. To do this, I'm going to set up my parentheses as follows. I'll put 3x in the first one and x in the second one because 3x times x is 3x squared. Now, since c is negative, that means that my two signs have to be opposing, and to get to 10, I will do 2 times negative 5. Now, here's the thing, compadres. This could or could not be the answer. To know for sure, we're going to have to FOIL out. Let's check. 3x times x is 3x squared. Then we have negative 15x. Then we have 2x, and then we have our negative 10 that we were after. Combining our two middle terms, we're going to get negative 13x, which, hey, that's not what we were looking for. We really wanted a negative 1x. So we have to kind of start over. But don't worry, it's very easy. Let's just switch the 2 and the 5 and see what happens here. So there we go, 5 and 2. Now we're going to refoil. We get negative 6x, and then we get plus 5x. And when we combine the two of them, we get our middle term, negative x. That means that 3x plus 5, x minus 2, is our answer. Sweet! Now in our next example, we have 2x squared minus 13x plus 6. So I'm going to be looking for two numbers that multiply to 2 and two numbers that multiply to 6. I'll set up my parentheses where 2x is in the first set and x is in the second set. Since my b is negative and c is positive, I'm going to have negative negative, and we'll do 3 and 2 for 6. At this point, I could refoil my answer if I wanted to verify whether it's true, or I could save some time by remembering the fact that the first and the last term in my foiling algorithm are going to remain unchanged in our final answer. In other words, I should be looking only at my O and my I, my outer and inner products here, because the combination of those should produce for me negative 13x. So let's take a look. Outer is 2x times negative 2 for negative 4x. Then we have negative 3 times x for negative 3x. Altogether, that gives us our negative 7x, and that's not what we wanted. Now, we could switch these two numbers, but we really don't want to have 2x and 2, so let's try a different factor pair in 1 and 6. So 2x times negative 6 is negative 12x, negative 1 times x is negative x. Together, that gives me negative 13x, which means that 2x minus 1, x minus 6 is my answer. Our last example is 4x squared minus 4x minus 15. So we'll be looking for two numbers that multiply to 4 and two numbers that multiply to negative 15. I'll set this up like my previous examples where we have 4x in the first parentheses and x in the second. And since c was negative, that means I'm going to have a plus in the first parentheses, a minus in the second parentheses. To get to 15, I'm going to try the combination of 3 and then 5. So now we'll test our outer and inner products. So we get negative 20x, and then we get positive 3x, which combine together to give me negative 17x, which, surprise, is not what I was looking for. So let's switch the 3 and the 5 and see if that gives us something that's a little more what we're looking for. We're going to do 5, and then we're going to do 3 to get negative 12x. 5x, and then negative 7x, which, man, this is bad. This means that 3 and 5 does not work in this arrangement. So let's try a different factor pair. Specifically, we'll use 15 and 1. So we get negative 4x, and then we get 15x, which combine together to give me 11x, which once again, not what I was looking for. We'll switch these two numbers again and see what happens now. So I'll have my 1 in the first parentheses, 15 in the second, which gives us negative 60x, and then positive 1x, which combine to give me negative 59x, and oh no, this is bad news. So oh no, what are we supposed to do now, my compadres? Well, remember, we were looking for two numbers that multiply to 4. And there's certainly a lot more factors of 4 than just 4 and 1, so why don't we try 2x and 2x? We'll maintain our plus and our minus here, and we'll try the combination of 3 and 5 one more time. There we go. So doing our outer, we're going to get negative 10x. Doing our inner, we're going to get positive 6x, which, oh my, we're going to get what we were looking for, negative 4x. So our answer is 2x plus 3, 2x minus 5. We did it. And with that, we can say, sweet merciful Meriwether, we have made it through this most difficult of factoring endeavors. If you have any further questions, please consult with the supplemental material or watch this video again. Now trust me, if you can do this factoring, you can do any factoring that you want. And if you don't believe in yourself, know that I believe in you. And with that, I will say good day to you, my compadres, and I will see you all next time. Later.